So today we'll talk about triangle sum properties. This stuff, we've actually shown one of these theorems earlier this school year. This one is the easiest though. How many degrees are inside of a triangle? Bless you.
3, 2, 3. 180. Okay,
How many degrees?
I heard that.
A triangle is, basically we defined it out as 3 non-collinear points.
180 degrees.
The sum of the interior angles, bless you, is always 180 degrees. Always 180 degrees for all of the sums of. You guys know a whole bunch about different types of triangles. You've all looked at them. You've all worked with them. Triangles can be classified different ways. Triangles can be classified by their side lengths. Triangles can be classified by their angles. Things like that. So what do you remember about types of triangles? Let's see if we remember here. So we have an isosceles. Are you guys okay if I just use that for isosceles? Because Lord knows I'm going to spell it wrong half the time anyway.
Sorry.
Isosceles.
Please try
That does not look
Is that
like
right?
isosceles.
Let's tone it down. Okay. I believe isosceles. What does an isosceles triangle have that other triangles don't? Nope.
I think it's like the triangle is split in half and it's like skin on both sides.
Close-ish. Gentlemen. An isosceles triangle has one set of congruent sides. Two sides are the same. Okay? And then if two sides are the same, you also get this. Base angle's the same. So isosceles triangles have one set of congruent sides and one set of congruent angles. The congruent angles are always pointed at, see if you can notice this. It's always pointing, see how this is pointing at that angle? This is pointing at that angle. They're always the ones across from the congruent side lengths. The angle that's between the two congruent sides is not the congruent angle. Okay?
So wait, isosceles and
Isosceles they have both two sides congruent and two angles congruent. So we write two sides. And we call those base angles.
The front of the Great Pyramid is an isosceles triangle.
Okay. What's another type of triangle? We'll go with right triangle first. I'll come back to your equilateral in a second. Can I go to a clean one?
Sure.
We all know everything about a right triangle. A right triangle has a right angle. What? I know. The right triangle has one right angle. Can it have more than one right angle? No. The other two angles must then be acute. These two guys would be acute angles. They can't be obtuse because if it's an obtuse angle, it would be more than 90. And then if you
They're both 45.
not necessarily, they don't have to be. What you're getting at with the 45-45-90 is a more specific right triangle. It's called an right isosceles triangle. Okay? That becomes, we worry about that a little bit later on, because yes, you can have mixtures of all these. Okay. One of the famous things about right triangles is that you can do this, and I know you guys all know that, where the C value is always the which side? The hypotenuse. The hypotenuse is always opposite what angle? Correct. It's always opposite the right angle. Okay, so you guys have all known that. It's not been anything new. Like Austin said a second ago, it is possible to have a right isosceles triangle. A right isosceles triangle would have the two side lengths congruent and two base angles congruent, and that's when he had mentioned that both base angles would have been 45 degrees. Okay. So that is possible. We spend a lot of time with this type of a triangle later on. It's the basis of most trigonometry, and that's how this stuff is going to work. Okay? So you can have mixtures of all these types of things. Mr. Pitts, you said, what was the other one you had? What triangle did you say it was? Equilateral. What does that mean? Do you remember? Very good. Equilateral triangle. An equilateral triangle has all three sides the same. If all three sides are the same, then all three angles are the same. If all three angles in the triangle are the same, what does each one of them have to measure? 60, very good. Okay? And this is another triangle that's the basis of trigonometry. All these angles are going to measure 60 degrees. Okay? What I mean by this whole basis of trigonometry is that later on next semester, we'll start dealing with right triangles that have specific side length values to them. A 30, 60, 90 triangle, a 45, 45 triangle. They all have special patterns that happen within them. You're going to get side lengths of 1, root 3, and 2 as they go through. There's a pattern that evolves. Okay, you don't have to worry about this now, but this is stuff that will show up. Then when you get to algebra 2, excuse me, you will deal with what's called the unit circle. The unit circle is based off of this triangle and that right isosceles triangle you brought up. They have 30 degrees, 45 degrees, and 60 degrees. And these angles bounce around the whole thing over and over again to create different values. It's the whole basis of trigonometry out of two triangles. Okay? So as you guys start to develop and learn about these things later on, you'll know where you're going to head to it when you get into algebra 2 and then pre-calc and whatever. There's one other type that we can look at as far as side lengths. Scalene, very good. What's a scalene?
A triangle that has no equal side.
Triangle with scales, did somebody say?
Yes.
Scalene triangle is not a triangle with scales. It would be pretty cool.
It has side lengths that are not equal.
Yeah, all three side lengths. All three side lengths.
One tick mark, two tick mark.
Yeah. All three side lengths are different. Example here. This is a right triangle, but it's also scalene because you got three different side lengths to it. So you can have a right scalene triangle. You can have, I'll ask you this one here in a second. So it is, again, like we've said, it is possible to mix these things together without too much of a hassle. I believe we've talked about all the different side length ones, right? We've had isosceles, equilateral, scalene. What about angles? We did right angle. What are the other types of triangles that you can classify when you deal with their angles? Do you remember that? Well, what are the different types of angles? Let's just start with that. You have acute and obtuse. So you could also have an acute triangle. An acute triangle just basically has all three acute angles. Whereas an obtuse triangle would have what? Oh, how many? One, very good. Obtuse triangle can only have one obtuse angle. So acute, obtuse, we did the right triangle, and from there. Okay? Questions? Once again, this is stuff that I'm pretty sure each and every single one of you guys has seen. Am I right in assuming that? No. No. All right. That's exterior angle theorem. I believe we did a proof that looked a lot like this not too long ago about setting up angles equal to or congruent complements or congruent supplements, I think. I believe we have. I think something very similar to this. This is actually really easy. Oh yeah, the linear pair one. Yeah, exactly right. Yeah. So what this thing is called the exterior angle sum theorem, or exterior angle theorem, basically states the following. What do you think an exterior angle is? An exterior would be outside. So if I'm going to talk about an exterior angle of a triangle, it's going to be the angle that's on the outside. I don't know. What do you think interior would be? This is really easy. It basically states this. The exterior angle is equal to the sum of the two angles it doesn't touch. The exterior angle equals the sum of the two angles it does not touch. Okay. It is very, very, very straightforward. I know there's a long-winded definition for it. There's a long, we actually did the proof last week of how this works. If you actually want to be so brave to go back in your notes, which I'm sure, reviewing notes is never helpful, ever. No, it's not. It's pointless. It's a long day today. That's how they go through. That's why too much. It equals the two it doesn't touch. Much easier. So let me show you guys an example of how this works then. Using the same basic diagram. Let me blow this up a bit so you can see it. If I'm going to figure out the value of x, we have to first draw a picture. I know.
That's hard.
I know. I know you can do it. I have faith in you. Okay. So, excuse me. So as you start these things out, once again, it's nothing more than drawing the diagram and figuring out the setup. That 2x minus 5, is that angle inside or outside the triangle? It's outside. Does it touch the other two angles? No, so it has to equal the sum of the two it doesn't touch. So basically, you wind up doing this. 2x minus 5 is x plus 70. What's x? Okay. Now, if you watch how this works, if you substitute that 75 in, obviously you get 75 degrees here. Are we okay with that? And then down here, if you double 75, you get a $1.50, right? A $1.50 minus 5 is 145. Now, how many degrees are inside a triangle? 180. If I take 75 and 70, subtract that from 180, what are you left with? How much? Use your calculator. 35. Notice, guys, enough. Notice, see how these two guys are supplementary? These two added up and supplementary to that. Hey, remember when we did that whole congruent supplements? Exactly. That's one of the reasons why this stuff works. Okay? That's one of the reasons why it works. I'm not going to make you guys do a proof of that. Not a big deal. Okay. What's up? Sure. Can I go to another one? It's not screaming numbers. Okay. Figure out what Y is. Yeah. 42!
It's exciting.
It's super exciting numbers.
Wow.
What's that? Remember when we've done this before? It's sometimes typesetting just looks weird. It's just, for some odd reason, they thought a degree symbol meant exclamation point. That's all. Don't worry about it. Okay. Don't worry about it. Oh boy, what's Y? 62. And it's that quick. It's equal to the sum of the two angles it doesn't touch. Okay. It equals the sum of the two angles it doesn't touch. Let's see if I can make this more difficult. Hi! Thanks. This one takes a minute or two to draw out to try to figure out what's going on. It's more of a wedge that can get a little messy. You will start to see more of these types of problems. So obviously the easiest place to start is the one triangle that already has two angles to it. So what's 65 and 45? So what's left over for angle 1? 70. Okay, there's 70. Now, 70, 45, and angle 2 create a line, don't they?
Yeah, 180.
What's 70 and 45?
70 and 45. Good question.
Bless you. 115. So what's 180 subtract the 115? 65.
There you go.
65 and 20 is how much?
85.
How much is left over for angle 3?
No.
That's the kind of stuff that you have to work on. I mean, it's not really hard math. It's just a matter of picking a spot and working your way out.
It's mental.
Well, I'd rather you have a calculator than mental, but you get the idea, okay?
I do physical.
I'm trying to think if there's anything else that's crazy. We'll do one more algebra one, then I'll cut you guys loose. Alright, try the algebra one again, please.
It's like who's getting sacked. Freaking offense. And the defense sucks. Defense really. So.
You're not going to be defense. Yeah, they're garbage. But they have a leader.
So again,
Without a good leader, without a good leader,
you've been in class for over half an hour. You got an answer. Come on, bud.
Intro runners, you don't need.
Yeah. He's the one who quit taking those hits and move out of the pocket like Peyton Manning told us. Tom Brady's just a straight up cheat. Yes, cheat.
Yes, Austin.
So,
This is the point of making sure you have something to write with when you come to class in high school.
Yeah.
Because I've already done all the notes for all that, this is just practice.
Do it out.
You might want to ask somebody at that point, or my wife brought up a good thing. It's my son even uses this. Ask
The
three
Indians only have
before me.
one game. Tomorrow, either tomorrow or
You need to ask three other people before you
today's
ask
travel.
me.
Travel to Cleveland.
They do that in second grade. My wife does it in high school. She does it in high school. It's a great idea.
Travel day.
And it's more often.
Who what?
Do. Hey, which one doesn't? Which two doesn't that touch? I can't speak today. Those.
Sorry.
Yes, ma'am. It's called the exterior angle. Basically, it says that the outside angle equals the sum of the two it doesn't touch. So that 6x minus 7 is the outside angle. It doesn't touch the 2x and the 103 minus x, so it equals them. Because it's about congruent supplements. There's a whole bunch of linear pair stuff that goes on. Combine your like terms, you're going to get x plus a $1.03 is 6x minus 7. Add 7, subtract x. Divide by 5, and what do you get? Double duck, quack, quack.
Was this just a solve for X
I
problem?
did the
or
math
plug it
wrong.
I think most. No, I'm not crazy. You played it, right? When they do I-22, they go double duck, quack, quack.
Well, not at the
Oh,
place
I see
over
what
on
I did.
Annie Gooden. They take their bingo really
See,
seriously.
All right, well,
Like if you're having a conversation, they're like, shh. So no, I think if somebody did that, they would like,
Throw 'em out.
they would like carry him out and throw him in the street. They don't fight. They don't
Rough 'em
fight.
up.
They're serious bingo players. Bingo.
There was a farmer who had a dog, and bingo was his name.
Are we supposed to be having fun?
Hey, let's do this. Homework stuff. In chapter 4 in the book, let's do.
Say none.
Yeah, I'm not gonna do order types.
Oh, yeah, yeah.
I'm thinking 14 through. Oop. Ah! Hit the wrong button. I hate the scroll on this thing.
14 through 15.
No.
Fine, 14 through 16.
Let's go 14, 36 evens. 14, 14 through 36 evens. It starts on page 221.
I'm a little spicy. You said 231. 220.
Okay? Yeah, I think it was. Yeah, it's page 221 on there.
This is chapter.
This is chapter 4. So on the tab, when we go back to the good old book here.
Boy.
Let's see here. So if you go back to the tab on the book, once this loads, click on chapter 4. Eventually. Gee, here's the tab to open chapter 3 and chapter 4 from the book. Convenient that I drew an arrow for you. It's crazy. So just click on it and it'll open it up, okay? I tried to make it easy for you. Sorry. I know. Would you mind getting the door for me, Reagan? Thank you.
Mr. Murphy.